of combining transformations of sinusoidal functions. We started off using transformation to sketch a graph of a trig function. Today I'll look at two other examples, and one of the examples we'll look at a transformation of a cosine function. The previous ones we look at sine. And the other part of the lesson we're looking at writing equations of the graph of a trig function. So the first part we've been sketching so far, sketching a transformation. So we sketch a sine transformation. Today we'll sketch a cosine. And the next part, the final part of this lesson, we're looking at writing equations, the equation of the graph of a trig function. And just remember, this is your transformation for either sine or cosine. And your A is your amplitude or vertical stretch or compression. Your B, in this case, would be a horizontal compression or stretch. Your C is your horizontal translation, or they call it the phase shift. And your D is the vertical translation. It's also the midline. We also see the midline. It's the maximum plus the minimum divided by 2, and the amplitude, the maximum value minus the minimum value divided by 2. So let's get the first example. And this one, the question is predict how the graph of y2 sine half x minus pi over 3 minus 1 related to the graph of sine of x. Now sine of x, as we know all along, it's a graph that started off, if you were to look at a sine function, it's a graph that started off at here we have degrees, but we'll probably use radian. So this is 1, the amplitude is 1, and here is your midline is 0. So your sine function of y is equal to sine x. Remember, x is 2 pi, or 360 degrees. So our sine graph would look sort of sine graph. Now, this is asking us, how is it related to it? Okay. First thing we notice here, this is our amplitude. And if you were to look at our equation that we had earlier, and this is our general equation, y is equal to AF. So your A is your amplitude. So the A is your vertical stretch in this case by a factor of 2. In other words, your amplitude is equal to 2. Right. Now, the horizontal stretch now, right, which is your B, this is your A, B, C, and D. Your horizontal stretch, remember, is 1 over B, absolute value of B. So this is 1 over 0.5, which turned out to be 2, a factor of 2. In other words, now you have a stretch, a horizontal stretch, a factor of 2. Also, this refers to the period. Now, the period here is 2 pi. So if you're doubling it, now the period is 4 pi. So let's just say by a factor of 2, it stretches by 2 more pi. So remember, the period is referred to as 2 pi over b, or 360 over b. So 2 pi over b will also give you, will now end up at 4, right? 2 pi over 0.5, which is equal to 4 pi. So the period now is 4 pi. So we have this horizontal stretch, factor of 2, the vertical stretch a factor of 2. Now we have a phase shift or a horizontal translation. So the C, pi over 3. So horizontal translation of phase shift of pi over 3 unit. And this goes to the right. Because it's negative, it goes to the right. And the D is your vertical translation. Which is down 1 unit. So if you were to look at our regular sine graph here, well, here's one period. We're going to so this will actually shift down 1 unit. That's 1. The amplitude now, instead of being 1 here, the amplitude here is 1. So we're going to double our amplitude. So that's how it's related to. So if you want to write it in a different way, so amplitude is equal to 2. Your period now is equal to 4 pi. Your horizontal shift is equal to pi over 3. Shift. And the vertical translation is equal to -1. So we're going to use all of this now to do our sketch. Okay, let's move a little bit here so we can see better. So first what I'll do, I'll look at my characteristics first of all. What do I have? Go back to my graph here. Let's go up this a little bit so you can see the page. So first of all, remember we have our amplitude is equal to 2, and the period is equal to 4 pi. Next, we have our horizontal shift. Pi over 3 units to the right. We have our midline, which is the same as D, is equal to -1. So imagine we don't have any shift, right? We will, first thing to do, you want to do step one, sketch the sine graph. Sketch sine graph. Sketch a sine graph without the horizontal shift. So we have an amplitude. First of all, let's look at our midline. Our midline is at -1. So now this is our new midline. Because the previous midline was here. Okay. So midline is our sine graph now. Now instead of being 2 pi, it's now 4 pi. So we'll sketch a graph. We'll sketch this graph now. Y is equal to 2 sine half x minus 0 minus 1. So we will include the phase shift, horizontal shift. We assume it's starting from the y-intercept here. Now the amplitude is 2. So what I'll do, I'll count up now. I'll start from my midline here, 1, 2. So this is my maximum line. So this is my maximum point, right? Because it wouldn't go higher. So we count 2 amplitude. And then 2 down. So this is my minimum line. So because we have 4 pi is a period, we need to have 5 critical points. So our first critical point, or main point, to be the first one, and the last one here. Then we need a midpoint, middle, and the middle between the middle, or 3/4, which is here. So we more or less divided up our period into 4 sections. So we know from our sine, go back to our regular sine graph, we start from this up, go up, the amplitude, come down to the midline, down to the negative, your minimum point, back to your midline. So let's do that here. So a point here, this is our maximum. Back to rest here. Oh, no. The midline is down here. Okay. So let's do that. So we have our first point, come back to rest, and then we go to the minimum here and back to a midline. So this graph here now is y is equal to 2 sine half x minus 0 minus 1. Right, there's no shift. There's a midline vertical shift, -1 unit. Okay, now we're going to go to the shift now. Our shift now is pi over 3 units to the right. Okay. So pi over 3 units to the right. Now I'll do this in marker. Do it in pencil first. So the pi over 3 would be here. So now we're shifting more or less to the right. This. So pi over 3 would be somewhere around here. There's pi over 2 here. So pi over 3 slightly to the right of it. Okay, so this is our new beginning. So if we come down here, we'll find that. Then the next one is pi over 3. So notice it's to the right here. So the next one will be here. So I'll use maybe yellow here. So this is my point here. This is my next point. So it's shifting to the right, pi over 3 units. So now this is my maximum. So put my maximum here. This would be my midline. Up here. So my graph now would be now. Notice they restricted me to a 4 pi, so I stop here. Now, if I were to continue, this will give you 4 on 1/3 pi. Okay, because remember you're shifting it by pi over 3. So this is already 4 pi, this point here, or it's going to be what? 13 over 3 pi. So beginning point here is pi over 3. So now if I were to extend this graph here, and that's your graph, y is equal to 2 sine half x minus pi over 3 minus 1. So here our amplitude. So if I were to write these characteristics out neatly here now. So our amplitude is 2. The period is 4 pi. Or phase shift is equal to pi over 3. Okay. Now our zeros, if we were to write those zeros, this would be pi over 3. Now this is 2 pi plus pi over 3. I said 2 pi is 5 over 3. So we have 2 over 3 pi. So here is our, oh, this is one here. So this is pi plus pi over 3. So this would give us 2 pi over 3 and 2 pi. So we can continue those are the zeros. So the zeros are going to be this point here, and this point over here would be 2 pi over 3. Okay, here we go. Oh, sorry, it's just 2 pi. So here is our 2 pi over 0 here. And this can give us 2 pi over 3. So this is our zeros here. And it doesn't get to 0 here. So my zeros are going to be 2 pi over 3 here and 2 pi. So zeros, 2 pi over 3 and 2 pi. Because that's where it crosses the x-axis. So your zeros are where it crosses the x-axis. So let's look at one, which I'll go here, and that looks at cosine. Now we've looked at sine. Now we're going to look at our cosine function. Now, first of all, let's look what the cosine would look like. Okay, so our cosine with a regular function of cosine, it begins. So we have a 2 pi. So y is equal to 1 cos theta. Now, if I were to write this in a transformation form, it will look like this: 1 cos 1 is going to be theta minus 0 plus 0. There's no vertical shift, no phase shift, and the period is 1, or 2 pi. So that's what it means. The 2 pi is a period. So if I were to look at this here, this is my midline. Okay, this is 0 here. Okay, so I have my points going to be up here. Oh, no, that will be sine. So now here are my main points. So cosine begins, remember, cos of 0 is equal to 1. So we start here. We know cos of pi over 2 is equal to 0. And we know cos of pi is equal to negative 1. Now we're using our unit circle in this case here, right? So the wonderful unit circle will come in handy. Next, we have, so we go down here. Then we have cos of 3 pi over 2 is equal to 0. And cos of 2 pi is equal to 1. So this is our cosine graph. Okay, so we'll refer to this one. Now, so we ask here to sketch the graph of half, 1/4. Now we have a quarter as the amplitude. So here's our amplitude. So this is the amplitude, you have B, you have C and D. And we're going to refer back to it. So now we know amplitude is equal to a quarter, or 0.25. Now, the period, it's interesting, is your b, right? So remember, b is equal to 3. So this is our horizontal stretch. So b is 1 over b, absolute value. So this has a horizontal compression. So this has a horizontal compression of a factor of 1/4, right? This is 1. So cosine here. So we have, okay, 1 over 3. So this is your b. Next, we have, so we have a, so the period here is 2 pi over b, which is 2 pi over 3. So period now, instead of being 2 pi, in the regular sign is 2 pi, now we have a period of 2 pi over 3. Our midline, okay, or d, is equal to 2 units up, which is our midline. And we have a phase shift of pi over 3. Okay. So we have a phase shift, or horizontal shift, pi over 6 units left. Now this is going to the left because it's positive. So first thing we'll do, we'll sketch a graph without the phase shift. Okay, so step 1, sketch cos graph without phase shift. So what do we have? So let's label this. Now, because we have a quarter, so we'll make this into 0.5, negative 0.5, we have 1.0, 1.5, 2, 2.5, we have negative 1, negative 1.5, negative 2, and negative 2.5. So we have our, notice, our midline is a 2. So this is our new midline. So we said our midline is a 2. So we'll just put a line here. Indicate to me that's my new midline. It's a guide. This is not part of the graph, but it's a guide to me. So this is my new midline, which is d is equal to 2, or the midline. Some books refer to a center line, but that's the same thing. So because our graph shifts now 2 units up, that's so we said that, establish that here. Now the period is 2 pi over 3. So instead of dividing up my grid into these, now I'm going to divide it up into pi over 6, because it's going to shift pi. That's giving me a good hint now. So sketch now, the next step, a scale of pi over 6. Use a scale called pi over 6. Because by doing that, you have a neat graph, because this becomes 4 pi over 6. So we'll have a neatly grid. So let's label this here. This is 0. Then this becomes negative pi over 6. And so I'll ignore these. These are not part of the graph anymore. I'm going to ignore these values here. So from here, I'll end up with pi over 6. This is 2 pi over 6. Let me get the, this is 3 pi over 6, which is half a pi. This is 4 pi over 6, which is 2/3. 5 pi over 6. I'll just write it in top here just to make it clear. Pi over 6 here. Then we have, or 1/3 pi. So 2 over 6, 3 pi over 6, 4 pi over 6, and 6 pi over 6, which is 1 pi. So we'll sketch it without, but look at our amplitude. Our amplitude is 0.25. So now this is our maximum. So it'll be 2.25 is our maximum, because our amplitude is a quarter. And our minimum, so our maximum value, and our minimum value should be right down here, be 1.75. So I'll put that in ink. So here is our 2.0, so our midline. Now, the period is 2 pi over 3, which is this guy here. 2 pi over 3, so we can put that here, which is 2 pi. So this is the end of the period of a regular sine graph, right? So 2 pi over 3. So we're going to make our cosine graph, so we need 5 critical points, right? So our beginning point here, sorry, our end, this is our beginning. Then we have our middle, and then a quarter and 3/4. So there we have our 5 critical points. Pi over 6. Now we'll construct our cosine graph, right? Now this is our maximum here. Let me be careful. So now this is my cosine graph. Regular cosine. So y is equal to a quarter cos 3x minus 0 plus 2. There's no phase shift in this one. Now, now we're going to go on to now, and after this, we sketch 1/4 cos 3x plus pi over 6 plus 2. Now we're going to go and sketch our graph. Now, what did it tell us? They tell us that they want this graph to shift pi over 6 units. Oops. Back here. Pi over 6 units to the left. So now pi over 6 units is down here. So I'm going to remove this from here because it's as we know this is 2. So pi over 6 is right down here because this is our new midline. So this is our minimum here. This is our midline. So now my graph now extends to this point here. That would be my new. But if I were to continue this graph, this is where it goes. But this graph now, instead of starting from here, it's now starting up here. So these are my point now. Pi over 6 is starting here. So it comes down. and it goes there. So it's shifting to the left, right? So now notice the gap there. So if I were to use my marker, this is my graph. Now, they want us to go continuously to negative 2 pi, so we can continue this graph here. So if you want to continue, and then it comes down here, goes up, it's there, and the trend continues. Oops. Okay, then it goes up there, comes down. So this graph now is y is equal to so generally what you would like to do is look at your phase shift and your scale, trying to make your scale, the beginning, your scale in whatever your phase shift is. It's much easier to graph that way. And always try to sketch your cos graph or your sine graph without the phase shift, but using your amplitude, the period, and then make the phase shift because it's easier. Now, that's not the only way. The other way is to find the 4-5 main points and then create your sketch based on your amplitude and your period. So those are two examples of sketching a graph. Now, in your textbook, you have a few more examples in your book. So let's look at some of the other examples to give you in your book here. And I'll post these answers, and I just wouldn't give you all of the answers here. So if you look at this in here, identify the transformation would be applied to this graph. Now, there are many possibilities for this one here. If you compare this graph with y of sine x, so remember your y is equal to a sine bx minus c plus d. From this, we have our amplitude is 10. So the graph has a stretch, right? So the a is equal to 10. So we have a vertical stretch. (10 units). So the b is 1/3. So if we have a horizontal, in this case, horizontal stretch of 1/1/3, which is equal to 3. So we have a factor of 3. In other words, the period is 3 times the regular. So if you were to use your formula, remember that wonderful one, it's so useful, the formula is so useful to use because it put it in perspective. So the period is equal to 2 pi over b. So we have here 2 pi over 1/3, which is 2 pi multiplied by 3, which is equal to 6 pi. That's why I said it's 3 times. The regular is 2 pi. So it's a factor of 3 times is stretch 3 times. So instead of being 2 pi the period, now it's 6 pi. The C is pi. In other words, it's a horizontal shift. Of pi units to the right. Remember, if it's negative, it's to the right. If it's positive, it's shift to the left. And finally, D, which is our new midpoint, is a vertical shift. 1 unit up. So still using this formula here, and remember, you can find your amplitude when we're doing our sketch. You can use your idea of the amplitude, which is the maximum minus the minimum divided by 2. So there are a few examples. You can go through these. I'll post these, try them out, and I'll post them on the blog. Now, what I want to go on to is to how do you go about writing an equation. So the first, we finished it. I'm going to switch gear here. So the next lesson, we're going to look at writing the equation of a graph of a trig function. Okay. So whenever we're looking at these questions, we are going to apply, as mentioned, some of the things we know. We know their amplitude from our previous lesson. We know is which is the maximum here. Okay. Maximum value minus the minimum value divided by 2. So they ask us to write it from a sign. Now, remember, our equation should be in the form y is equal to a sine b x minus c plus d. So we have to write this equation in this form. So what are we looking to find? We are looking to find a, b, c, and d if they're other than 0. Once we have the a, b, c, and d, we substitute the values in here, and we have our equation. So first thing is the amplitude. So the amplitude here, we have here is our maximum, and here is our minimum. So it's negative 0.5, and this is negative 5.5. So our new so we can define our amplitude, and our amplitude is going to be negative 0.5. Oops, I should put that here. Minus 5.5, which is negative. This is plus here. Is 5. Oops. 5 over 2. So our amplitude here is 5/2. We can put that on there for now. Next, we want to find our midline. It's probably easier to do. Your midline, which is your D, okay? Your midline is D. And that is your max plus your minimum divided by 2. So your max plus your minimum divided by 2. Remember, your midline is your halfway between your maximum and minimum. You can eyeball it here, and you probably could work it out. But we're not going to eyeball it. We're going to use it exactly as it's much easier to work. So we already have it here. It's 0.5. Oops, divided by 2 here. So we have negative 0.5 plus negative 5.5 over 2, which is D. So we end up with negative 6 over 2, which is negative 3. So our midline, so here is negative 1, negative 2, negative 3. This is our midline. So right over here, midline. Or center line. I think your textbook uses center line, but other textbook uses midline, which is the same thing. Now we got our D, which is negative 3. The next we want to do is, so we have just the A. We have the D. So we're going to find the B, which is B, which is the horizontal stretch. But we need to find the B. The B is equal to 2 pi over the period. So we have to go and find a period. Okay. So now we're referring to a sine function here, right? So that's our main thing. We're looking at a sine function. So this is our midline. So if we're looking at the sine function, we're looking at a period. The period, we can measure it from maximum to maximum, or midline to midline. This is a complete cycle. And notice, this is, if you start from the beginning here to here, it's a half a pi. So the period for this sine function, so the period is maximum, right? It's a distance here. So the horizontal point here, so from here, so we have here, it's a quarter, is a pi over 2, or half a pi, and 0. So we have the length of it going to be pi over 2 minus 0, which is pi over 2. So this is here, the entire length from here to here. This is pi over 2. So you have a period of pi over 2. Right? So the B, so because it's a sketch, you have to look at the graph. There's no way of figuring it out because it's not an equation. You're trying to develop the equation. So here we have 2 pi over 2, which works out to 2 pi multiplied by 1, oops, pi over 2. It would be, oh no, we had to turn this around. See, dividing 2 over pi. Oops. So we're dividing. So this pi will cancel, will give you 4. So the b is equal to 4. Now, the last we need to find is your c, is your phase shift or horizontal shift. Now, the horizontal shift, it all depends on where you want to start. So if we're starting from here, okay, we'll have a negative sign function. But if you start from here, we'll have a positive shifting, right? In other words, you're saying this graph, instead of starting from here, it starts from here. Now, each one of these grids is pi, this is pi over 4, this would be pi over 8. So you can use here as this is your starting point. So that will give you 3 over 8 pi. That's we're going to start from here, be negative. But if you were to start from here, this is positive. Now this is pi over 8. Because each one of these grids are pi over 8. Okay, because half of a quarter is pi over 8. So horizontal shift would be positive pi over 8 if you started from here. So I'm starting from here and give you pi over 8. Now, if you were to start from here now, which is a sine, because we need a sine function, now this will be 3 pi over 8. So it depends on where you are using your shift to be. Okay, and they'll all be the same result. You can even start from here too, right? If you want to start, but because this is a continuous graph, I'll use this one for now. So it's now pi over 8. Now, if you use this guy here, it's 3 pi over 8, and this will be negative now. So we can put all of this together. We can say y is equal to your amplitude of a sine b into x minus c plus d over a. So we have a is equal to 5 over 2. B is equal to 4. C will use as pi over 8. And D as negative 3. Okay, so we have a negative 3 there. So y is equal to 5 over 2 sine. B is 4x plus pi over 8 minus 3. So that's our graph. Now you can write it as a cosine function too, right? This could have been written as a cosine, but now it's starting from here. Switch it around, then this would be 0. Be the same function. In other words, it could be written, if they'd ask you for this to be in a sine function, a cosine instead of sine, cosines start from the y-intercept, the maximum value here. And if I were to write this as a cosine function, which you could, it's going to be y is equal to 5 over 2 cos 4, almost exactly everything x now plus 0. Oops. Because he has no shift, right? Minus 3. This would be the cosine, and it would be the exact graph. So that's sketching a cosine using a sketch to determine the equation. Let's look at one more example. Write an equation of so if you look at this example here in terms of sine, it should be all in terms of sine. So we have our so we have to write it as y is equal to a sine b into x minus c plus d. So first thing we want to do, we want to find our maximum, which is up here. So maximum minus or minimum equals 8. Our minimum is negative 4. So our maximum is 6 minus your minimum divided by 2, which works out to be 10 over 2, which is 5. Okay. I need to give myself some space here. I'm running out of room here, so I'll put here 6 minus 4 over 2, which is 10 over 2, which is equal to 5. So our amplitude here is 5. Okay. Now we need to find our midline, which is and then those. So midline is your maximum. D is your maximum now plus your minimum. It's like finding your average, right? Which is 6 plus minus 4 divided by 2, which is 2 over 2. And those give us 1. So now this is our midline. And you can verify it. We said my amplitude is 5, so I go up here. So I start from 1. So this should be 5. So we have 1, 2, 3, 4, 5 going up. You should have 1, 2, 3, 4, 5 going down. So it tells me this is 5, and this is also 5. So that's your amplitude. So now we've got our D. Now the B is a 2 pi over the period. Now to get your period, you're looking at, in this case, probably easier to look at minimum to minimum. This length here is the period. You can also go from here to here, but it's very difficult to read off these values here. So if you look at this here, we have divided into 12, right? Because this is going to be 2/12 now, because this whole thing now is divided into section of 12. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have a pi somewhere here. So we have 12 over 12 pi. So each one of these grid here is 1/12 pi. This is a half of pi over 6. So we're starting from the period start from 1/12 pi, and this goes up to be 2, 3, 4, 5, 6, 7, 8, 9, 12. So this gives us 8, 12. So the period which is equal to 4. Oh, this will give us what? 2/3? Yes. 4 divided by 2, and this will give us 4. No, 3 here. So the length of the horizontal distance here is 8/12. So we have, remove this from here, that's too cumbersome. So the period is 2 over 3 pi. So we have 2 pi divided by 2/3 pi, and that worked out to be 3. So B is 3 based on the period. The last thing we want to do now is to find C, which is our horizontal shift. Or phase shift. Now we have to look back to our midline here. And we look at the sine function. It starts from here, or you can start from here. I'm using the first one. Now we can't read the one on the left side, so we're going to go with it. Now this is going to give us what? A phase shift of a quarter. This would be pi. So now, roughly. So now we have a phase shift, a possible one of a quarter pi. Okay, because here this is a quarter. Or 2 pi over 6. So this line here is 2 pi. Oh, sorry, this is not be 2 pi over 6, it'd be 3 pi over 12. Okay, because this is 1/12 pi, 2/12 pi, 3/12 pi, which is 1 over 3/4 12, a quarter pi. So we have a horizontal shift of 1/4 pi to the right. So there are our values. So possible equation then, you can write it up here, is y is equal to, or a is 5, sine 3 is our b, x minus a quarter, so we can put pi over 4, close bracket, and our vertical shift is plus 1. So that's our So just remember, whenever you're asked to write an equation, start off finding your amplitude, your midline, and then find a period. Once you have your midline, then you can figure out your horizontal shift. But also be careful about labeling. Be careful because many of these are in fractions, so you have to be careful with your fractions. And you can simplify to get to. So today, we use transformation to sketch a graph of a trig function. So first we look at two examples, and we look at two examples writing equation of a graph of a trig function. So you may want to try some of the examples in your textbook, and in our next lesson, I'll take up some of those questions, but I'll post the answers on the blog. And the final part of this lesson, or this section of the course, is looking at applications of sinusoidal function, which is lesson 6.7.